My name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math questions out of this book here, the official guide to the GRE, the revised general test. If you do not own it already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 242. Page 242. Today is our lesson number 132. Let's take a look at it. We are dealing with the concept of shifting of graphs. How do we shift graph? We saw day before yesterday. Today is our 132, so not day 131 but rather day 130. On day 130 we saw that the graph of y equals to absolute value of x looks like this. When x is 0, y is equal to absolute value of x. When x is 0, y is 0. When x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. And now, when x is negative 1, absolute value of negative 1 is positive 1. Absolute value of negative 1 is positive 1, so y is again 1. When x is negative 2, y is again 2. When x is negative 3, y is again 3. So for the negative values, we also get positive values of y. So we get 1, 1, we get 2, 2, we get 3, 3. And what we found yesterday is that the shape of the graph is like this. This is what the graph looks like. What we're going to do today, so that was the absolute value of x. What we're going to do today we'll pick up this graph and shift it up 2 units. Let's draw it freehand. So we can see it. Actually, I don't want to draw freehand. 1, 2, 3. 1, 2, 3. 1, 1. 2, 2. 3, 3. 1, 2, 3. 1, 1. 2, 2. 3, 3. One, 1, 2, 2, 3, 3. Let's shift it up 2 units. We're going to pick it up. We're going to literally pick up the graph and move it up 2 units. As a result, whatever values of x that occurred before for a given values of y, in other words, whatever values of x is corresponded with the given values of y, now Now, as a result of picking it up and moving the graph up 2 units, now the same values of y, same values of x rather, will take place when y is 2 units more. Y is 2 units more. In other words, our new function will be, well, the old one was, what do we call the old function? Oh, we didn't give it a name, we just said y equals the absolute value of x. Y equals, right here, let's call it f of x, which is y equals to absolute value of x. So our new function, let's call it g of x, let's give it a name of g because we have f there, would simply be the absolute value of x that was there plus 2 more, that's it. In other words, listen very carefully, in other words, when you move it like this, when you move the graph up or down, listen very carefully, when you move the graph up or down, well, the mathematicians don't call it move it, they call it shift it. When you shift the graph up or down, what is affected is the value of y because you're going along the y-axis. It does nothing to the x. We don't have to make any compensation to the x. We only do any compensation to the x values if the values of x are somehow affected, and that will only be the case when you pick up the graph and shift it along x-axis. Then you have to ask yourself, well, how do I compensate for the fact now that the values of y that occurred before for a given value of x, now the same values of y are taking place for a different values of x because it's been shifted along x-axis. That is not the case here. We are moving it up and down. In this case, we are moving it up. So whatever values of y that were there, it's just going to be 2 units more. So for example, let's do it here. Before x was 0, before y was 0 when x was 0, now y is going to be 0 when x is 0. Oh, sorry, now y is going to be 2 when x is 0. Before y was 1, before the y was 1, I shouldn't have put the red part there. Before y was 1, when x was 1, now when x is 1, well, now x is 1, y is going to be 3. 1, 2, 3, right here. Before, when x was 2, y was 2. Instead of 2, now it's going to be 4. As you can see, it's a new graph right here, which is parallel to this line, is parallel, this red line, is parallel to this black line. It's supposed to be parallel, mine is not because mine is not drawn very well, but it is parallel to the red line. It's just been shifted up 2 units. It's just been shifted up. All of distance, I'm going to show you here with my hand. This distance here is the same distance as this distance same, this distance same. They're all 2 units. It's just been lifted up by 2 units. That's all it is. We do not have to make any sort of compensation, any sort of adjustment to the values of x's, y, because we're not moving along the x-axis, we are moving along the y-axis. Now, had we picked it up and shifted it downwards on the y-axis, we would have had to subtract it. Our new function, let's put it here, g of x. Our new function g of x is simply x, absolute value of x minus a 2. Oh, sorry, plus a 2. We are shifting it up, plus a 2. This distance from here to here, as you can clearly see, is 2. All of these distances are 2. This distance is 2. So is this distance. This distance is 2. As you can see from here to here is 2. 1 and 2. All of these distances are 2. It's just been lifted up by 2 units. That's all it is. So what you have to keep in mind is that when the graphs are shifted up or down by a given number of units, all you do is simply add the numerical value to the function, which is what they're talking about here. If you look at the page number 242, right below the graph, it says, I'm going to read it to you, it says in general, for any function h of x and any positive number c, the following are true. The original function plus some numerical value c is the function of the original graph shifted upward by c units. That's exactly what's going on here. Our c equals 2 here. I'm going to read one more time. There are four bullets. That's what I'm reading here on the page. Right here in the middle of the page with the 4 bullets here. The top 2 lines is what I'm reading. Similarly, if you have a graph, if you have a function, if you subtract certain constant from it, c is the constant here, if you subtract certain constant from it, then what you're going to end up is the same exact graph, but shifted down by that number of units. Here it's shifted up by 2 units. Let's do very quickly one more graph, and we're going to erase all those things, and I'm going to show you quickly one more graph. Very simple, very straightforward. That was f of x. F of x equals absolute value of x. We call this function g, f, g, let's call it h. H of x is absolute value of x minus 7. Well, what would that look like? Very easy. Here's your graph, here's your original graph, and you shift it down by 7 units. If this is negative 7, it's going to be exact same graph, shifted down by exactly 7 units. And this line is parallel to that line is parallel to that line, and these distances that you see are all 7 units. They're all equal. No matter where you go, these distances are vertical distances are all 7. Exact vertical distances, they are all 7. Because that's what has been shifted up. It's been shifted, not shifted up rather, in this case shifted down because it is negative 7. So the y is just 7 units less than before. That's all it is. Which is why we're subtracting 7 from the entire function. The function itself did not change. You see, the relationship between the y, this is the y value, h of value of the function is the y value. The relationship between the y and the x did not change at all. They behaved to each other in the same manner, except those behaviors are taking place few units down the axis or few units up the axis. But the relationship does not change. But when you start changing the value of x, when you start moving it right or left, then the function itself is affected, and we have to compensate the values of x in a careful manner, which is what we're going to do next. What we're going to do next is to shift the parabola that you see there along x-axis, and you will see how we have to adjust for that. Here there is no adjustment. It's very easy to see. If you're moving up 7 units, you simply add 7 to the function. If you're moving down 7 units, you subtract 7 from the function. Here we're moving up 2 units, so we just add 2 to it. That's all. Tomorrow we'll see how to shift the parabola along x-axis, as I said, which we have done before. It's not that there's something that we have not done, but since they're doing it again, I'm going to do it one more time tomorrow, where we'll take this parabola and shift it to the left by 1 unit along x-axis, that is. Do you understand? I'll see you tomorrow, okay? Bye now.